Hello and welcome to SudoKanard. Sudoku Grand Prix is approaching, round 6 organized by Ukraine and more precisely by Ukrainian author Serhiy Chichenko. I hope I didn't butcher his name. And this puzzle will feature a very rare variant of Sudoku, which is called X-average. And I chose this practice puzzle by the grand puzzle master Richard Stolk from the Netherlands. He called it X sums average, but it's the same set of rules. So the set of rules is that whenever you have such a number in the margin, then the number is the average value of the first few digits, and how many digits is given by these digits. So imagining that, what am I doing? If you imagine that this is a 6, then 4 is the average value of those 6 digits, which means that the sum of those 6 digits is 24, which is a possibility. So I've already solved this puzzle, and I hope I will do it again correctly. So 2 is the value of the first few digits. If I try to put one digit, then the average value is 1. That's not possible. If I try to put a 2, then the average value of those 2 digits must be 2, which means that this will have to be another 2. That's not allowed by the rules of Sudoku. If I try to put a 3, then it means that that's 3 in the corner first, and the sum of those 3 digits should be 6, which is feasible with 1 and 2 there. So 3 is a valid option for this 2 clue. What about 4? Well, it means that the sum of 4 digits is 8, which is impossible because the minimum value is 10. And the same happens if you try to put a 5 or something bigger into this cell. So the only possibility is to have a 3 here, and that's 3 in the corner, definitely. Then 1 and 2, but if you try to put a 1 here, you can't have an average value of 5 with only one digit equal to 1. So that's actually the 2, and that's the 1. So those 2 digits must sum to 10, which means that this is 8. And that is a quite straightforward beginning. So where do we go now? So an average value of 3 seems to be quite restricted. So we know that this won't be a 3, so it could be a 2 with a 4 there. That seems to be a valid option. A 4 here would work. That would be a sum of 12, which would work with 1, 2, and 5. And that would be the only option. So 2 would work, 4 would work. What about 5? 5 would mean that the sum here is 15, which is possible with 1, 2, 3, and 4 here. Except that that would not work at all because of the 3 on the other side. You can't have now an average of 3 if no digit below 3 is available. So 5 is not an option. And actually, I'm starting to think that 4 here won't work either, because if I put 1, 2, and 5, how will I have an average of 3 with only 3 being not bigger than 3? If I try to put a 3 here, that the other digits will be bigger than 3, so the average value of the first 3 digits won't be 3. So if I just sum up all that I have said, this has to be a 2, and that's a 4. 5 is probably the least constrained digit as a clue, because you could have a 2 plus an 8. That's an average value of 5. Just like in this position, you could have a 3 with 2 digits summing to 12. You could have a 4 with 3 digits summing to 15. You could even have a 9. The average value of the 9 digits is 5. you could have an 8 here with 8 digits summing to 40 and a 5 here. Well, a lot could happen where almost any digit would work here. Even 5 would work. So 5 is really the least constrained clue in this case. 7 seems to be much more constrained, because then the sum of all 7 digits here must be a multiple of 7 first. So what are the options? And if I recall correctly, the only options are 4 and 5. This is what I had deduced. If I try to put a 2, then this must be 12, not valid. 1 is excluded. If I try to put a 3, then the sum of those 3 digits must be 21. But here I can't make 18 with 2 digits, so 3 is not an option. I was saying that 4 and 5 work. Actually, 4 would work with 7, 8, and 9. That's a total of 28. So this is possible. And 5 would work. We would need a total of 35, and 35 is the sum of all biggest digits. But actually, this option doesn't work, because now, where in this column do you put 2 and 4? Because of that, they are not here, and they can't both be in this cell. So 5 is not an option here, but it will be an option here. Let's put it like this, and now it's excluded from here. And if I try to put a 6, then it means that the sum of all 6 digits here is 42, and then the sum of those 3 digits must be 3. That's not possible, and bigger digits fail for the same reason, so that this is actually a 4, and for the same reason only 4 and 5 were admissible in this cell, so that this is a 5. And we must now have 7, 8, 9 here, and 6, 7, 8, 9 in there. Next is this 6 clue. 9 won't work. The average value would be 5. If I try to put an 8 here, then it means that the sum of those 8 digits must be 48, which is impossible. The maximum sum is 44. So what about 7? 7 would seem to work. We would have 42 as the sum of those digits, and those would be a 1 and a 2, except that 1 and 2 are not available, and 1 and 2 here would never work with the clue 4. So 7 is excluded as well, and this is actually a 6. I was about to say that 9 must be excluded from here, but that's wrong. I said earlier that basically any digit would work here. Now this 6 is interesting. We have a sum of 36, so the sum here must be 9. Without using the 6, so the sum must be either 2, 3, 4, or 1, 3, and 5. An interesting point is that with this, we know that this must be 4 or 5. And those must be from 1 to 3, so 5 with 1 and 3, or 4 with 2 and 3. And there is definitely a 3 in here. If I try to put a 4, then those 4 digits must sum to 16, which is possible with a 7 here. If I try to make it 5, then we have a 9, then we must have a sum of 20 here, with 9 here, so this must be 11. And that would work with 9 and 2, with 1 and 3 here. So we have 2 options. And that's the only options. 8 plus 3 wouldn't work, and 9 plus and 7 plus 4 wouldn't work because of this 4. What did I just say? I said that 9 and 2 would work, but there's a 2 here. So I was wrong. So actually 5 doesn't work at all. and this must be a 7. And this 2 here must be in here for this column. Now what do we see? This 3 clue. This digit can't be a 4, it can't be a 5, it can't be a 2. So the only valid option is a 3. We must have a sum of 9 without using the 4, that must be a 1 and a 5. And I'm seeing that 2 and 6 won't be here, so they must be there. And this is 8 or 9. Now, what do we have? This 5 here is not in here, so on this row, 5 must be here. And those are from 1, 8, and 9. This digit now is very constrained. It can't be 3, 4, 5, or 6. So what could it be? Could it be a 2? No, a 2 would go with a 6, which would repeat. So we're left with 7, 8, or 9, but 9 is much too big. 8 wouldn't work because now we would have a sum of 32, and we would have to put a 13 in this cell. So only 7 works. I can remove this 7. So there is a 7 somewhere here. So with this 7, we know that the sum of all 7 digits here is 28, which means that the sum here is 17, which is an 8 and a 9. And that is a 1. 3 and 4, they are not here, they are in here. That's a 2, that's a 6, that's a 2. Here I need 1, 8, and 9. We can remove some options. Those are 5, 6, and 7, and we can't remove any option. Here we must have 1, 2, 3, and 4. That's not 2 or 3, that's not 1 or 4, that's not 2, that's not 1 either. And this is probably the next place to look. Perhaps this 6. This 5 is not that much constrained, as I mentioned earlier. So what about this? If I try to make this a 3, then those 3 digits sum to 12. 4 and 5 work. I can't make 1 and 8, 2 or 7, 3 or 6. So 3 works with 4 and 5 only. And that's interesting because if that's a 3, then 4 is there. If that's a 4, there, well, 4 is there. So there is a 4 in here, which means that this is not a 4, that's a 1. And because there's a 4 in here, I must have a 4 somewhere in there. And those are from 5, 6, 7, 9. That's not so interesting. Now what about this? So if this is 3, then we have 4 and 5 here. If this is 4, we must have 16 in here. So 16 in here plus 10, that's 26, and we must have 19 in here. 19 without using the 8, it must include the 9. 9 plus 3 and 7. 9, 3, and 7. So that's, well, which means that in this case we have 1, 5, and 6. That's correct. 1 in here, no, 1 in here, 5 and 6. So in both cases, we must have the 5 somewhere in here. So that was 3, 4, 5, or 4, 5, 6, and 1. So 5, 6, or 4, 5. Something else I'm seeing. This digit is nowhere in here. In this column, it must be here. And it's not an 8, so it has to be a 9. So that's the 9, that's 8, 9, 8, 9, and no 9 in here. Here we're left with 6, 7, 8. And I'm seeing that just by standard Sudoku elimination, we get a 2 in here. One is somewhere in here. 7 is not here, it could still be here, could still be here. Doesn't seem so interesting. So at some point I will have to address this 5. Yes, this 5 is interesting because 5 is the sum of a certain amount of digits. And we can narrow down the amount of digits. 1, 2, 3, 4, 6, 9. So this is from 5, 7, and 8. But 8 here would mean that the sum here is 40, and this would have to be a 5. That doesn't work. 7 here would mean that the sum of those 7 digits here is 35, so the sum of those 2 digits is 10. This is not the case. So 7 is ruled out, and this is actually a 5. So the sum here is 25, so the sum here must be 20. And we have 17, so this is a 3. And this 4 goes in there. Here we have 1, 7, and 8. Well, digits from 1, 7, 8, to be more precise. 4 here would put the 1 here, so this is totally working. And I'm saying that 7 and 8 are not in here, so in this column 7 and 8 must be here. So this is 7, this is 8. So this digit, well, let's just resolve that. So this digit is not a 1, so this digit can't be a 4. 4 would put the 1 in here, as I mentioned earlier. There is a 1 in here, and a 5 in there. So this is actually a 3, that's a 4, and here, what did I do? We have 4 and a 5, and this is 6 and 7. And here we have the 1 and the 6. Here we have the 3 and the 6, so this is 7, this is 6. Here we have 5 and 9, but 9 will never work with the 6. So this is 4, this is, here we must have 5 and 7. This 9 makes this a 1. That's not a 6. So the sum of those 4 digits must be 24. We have 10, we must have another 14. 7 plus 7 won't work. That's a 5, that's a 9. And up there I get the 7. I get the 8 and the 9. And those are from 1 to 3. And with those 9s and this 9, I get 9 in here. Now, how does this resolve? What is left to do? This 4 is fulfilled. I think this 5 clue here is the only clue that hasn't been resolved yet. So we know, oh, if this is 8, and those 8 digits sum to 40, then this will have to be a 5. If this is 7, then those 7 digits sum to 35. So those two digits here must sum to 10. So what are the options for those two digits to sum to 10? If this is a 7, then those won't be 7 plus 3, they won't be 9 plus 1, so they must be even digits. So we could still have 2 here and 8 there, I think. Or 4 here and 6 there. So this is from 6 and 8. And this is not over yet. Oh, I've been missing this. This 4 makes this a 1, that's a 4. And with those ones, I get a 1 in here, and that's a 2. 3, 2, 1. This is from 3 and 5. So what was I saying? 8 here plus with 5 here. I'm seeing that 4's place a 4 in here. I still need a 3 somewhere. So this is from 3, 5, and 6. And that's interesting because now, because of this 2, we can't have 2 and 8 as options that I mentioned. And actually, those two digits can never sum to 10. That's correct. So this finally is not a 7, that's an 8. This is 7. And now this is a 5, because those 8 digits sum to 40. So now I get the 6 here, the 5 there. The 2 here, the 5 there. The 3 here, 4 and 3, 5 and 4. This 3 now gives those digits. This row needs 6 and 7. There's a 7 here. This row needs a 5. It's here. That's a 2. That's a 7. And that's an 8. And that's it. Well, actually, puzzle doesn't include solution, but I'm pretty confident that this is working. So very nice puzzle by the professor, Richard Stolk from the Netherlands, from his legendary Sudoku variant series. And this is a very good practice puzzle for the upcoming Sudoku Grand Prix. So I hope this will help you if you attempt this puzzle. Thanks for watching this video. See you soon on SudoKanard.